eTouchSciences has created an exciting new way for students to explore scientific principles by adding the sense of touch to computer-based learning. These interactive software applications are changing the way students learn science and are bringing accessibility to the next level for students who are blind or visually impaired. eTouchSciences apps add a sense of touch to math and science topics that are currently being presented visually. Adding a sense of touch to math and science content is not only effective for students with visual impairments, but it gives any student additional information by introducing concepts through another learning modality. Providing learning accessibility is very important to both students and their teachers. The requirements of the Americans with Disabilities Act and the Individuals with Disabilities Education Act protect the rights of students with disabilities, providing for equal access to education and protection from discrimination. eTouchSciences apps help fill the gap in the math and science classroom for students who need the information to be delivered in an alternative form. Utilizing a revolutionary technology called computer haptics, the computer software apps along with the Novant Falcon make three-dimensional virtual objects on a computer screen touchable. The Novant Falcon allows you to touch the virtual object pictured on the computer screen. Here, you can see how a person holds the round grip on the Falcon control and moves over the bumpy sphere in the virtual scene. The device has 3 degrees of freedom. You can move up, down, left, right, or in and out. This allows for the full exploration of a 3-dimensional space. This durable device gives force feedback and creates tactile sensations for the user. The device can simulate many physical phenomena, such as textured surface, magnetism, elasticity, viscosity, and many more. From the screen capture, you can see how a student can navigate through a 3-dimensional virtual scene using the Novant Falcon device. The student can feel the shapes and textures of virtual objects. The first example is a math lesson on 3-dimensional shapes used to orient the students to the haptics device and how they can use it to feel virtual objects, shapes, and textures. This shows a virtual sphere, a golf ball, with a bumpy texture. The student can feel the shape and texture and will hear verbal commands about what they should be doing in the scene. Then they can press a key to get a question to check their understanding of what shape they are feeling. Here you can see a virtual cube, a cement block, with a rough, sandy texture. This scene shows a virtual cylinder, a soup can, with a smooth texture. This simple app has 9 different scenes to allow students to learn to use the Novant Falcon device, learn the keystrokes to move through the software, and practice answering questions. The next example shows a scene from the science lesson exploring the atom. The students can navigate through the atom, getting tactile and force feedback about the different parts. They can enter the nucleus of the atom, where they can feel the protons with positive charges slightly pushing them away. They can touch the neutrons with no charge, but a rough texture to distinguish them from the protons. As the students move through the nucleus and touch the protons and neutrons, they are given verbal cues, P1 or N1, telling them which of the parts they are touching. As the students move outside the nucleus of the atom, they can enter one of the electron shells. The electron shells are magnetized, so the student can follow the shell until they bump into an electron. The electron has a slight attractive force. Again, the students will hear verbal cues like E1, so they can count the electrons. This information allows the students to identify the number of protons, neutrons, and electrons that are in the scene. We are showing the full 3-dimensional virtual model of the nitrogen atom with 7 protons, 7 neutrons, and 7 electrons in 2 electron shells. The eTouchSciences apps adhere to the best practices for developing software for students who are blind and visually impaired. They include touch, sound, and visual to engage all learning modalities, high-contrast graphics, clear audio instructions, consistent keystrokes, and also include other great educational features such as embedded self-checks. Listen to some testimonials from students and teachers.
I like the haptic device because it is a fun and educational toy. It is a new style of learning and I think it will be very useful for anyone who uses it. I especially think it is a great device for blind and visually impaired students. I'd give it 3 thumbs up if I had another hand.
Apps give the students another engaging way to interact with the world around them. By meeting national science standards, this product should be used in every school to assist in teaching visually impaired students.
eTouchSciences apps and the Novum Falcon are changing the way students learn science and bringing accessibility to the next level for students who are blind or visually impaired.